Welcome back. Let's have a look at the remaining questions in this paper. So the next question says, Jack bought a new boat. Sorry, I'll start that again because I don't think you could hear. Sorry. Okay. 3, 2, 1, starting now. Jack bought a new boat for, sorry, didn't do the introduction. Welcome back. Let's have a look at going through the remaining questions of this paper. So question 9 says, Jack bought a new boat for 12,500. The value V of Jack's boat at the end of n years is going to be given by the formula. At the end of how many years was the value of Jack's boat first less than 50% of the value of the boat when it was new? Right, let's look at 50% first. Obviously, half 12,500, it gives you 6,250. Right. All I'm going to do is trial and error. I'm going to put in different numbers. Okay. 9031.25 after 5 years, that's the value. After 4 years, let's do then, just making a guess. 6525.08. Oh, we're getting close, aren't we? Right, 12,500 times 0.85 to the power of 5 then. Let's go a little bit up. 5546.32. Right, after 4 years, the value is actually £6,525, but we want first less than 50%. We need it to be less than 6,250, and obviously that's the 5 years. So I'm going to write down 5. The next one says a savings account pays interest at a rate of R% per year. Jack invests £5,500 in the account for 1 year. At the end of the year, Jack pays tax on the interest at a rate of 40%. After paying tax, he gets £79.20. We have to work out the R. All right, so, okay. I'm going to say £79.20 is equal to 60% of the value because he's paying an interest rate of 40%. So 100 take away 40 is left with 60%. And obviously he's paid the tax and he's left with that. Let's work out what 100% would be. So I need to work out 1% first by dividing by 60. That's 1.32. I can work out 100% now by timesing by 100 to get £132. Right, so he invests £5,500 plus the £132 is £5,632. Now what I need is to know 5,500 times what would give me 5,632. Well, to work that out, I can do 5,632 divided by 5,500, and that gives me 1.024. Well, the 1 represents your 100% value, which is 5,500. So I'm just interested in the decimal, which is 0.024. Because I want the percentage, I need to times that by 100, and that's 2.4%. Simple and straightforward. Okay. Question 10. So we've got probability here. We've got some counters in a bag, and you've got a random counter. We have to work out what getting green is. So obviously we have to add these up. See what we get. Get 0.95. Obviously a probability always adds up to 1. So I've got to do 1 take away 0.95, and that gives me 0.05. That's my answer. Right, what is the least possible number of counters in the bag? You must give your reason for your answer. Okay, so we have got that there is 0.05, isn't it? And we know that counters must be whole numbers. Can't have a decimal of a counter, we can't have fractions. So we know that the probability of getting a red, because that's the smallest number there, isn't it? 0.05 is actually the smallest. So I'm going to say there has to be one red counter. Yeah, definitely can't have no counters at all. So if I say 1 out of something gives me 0.05, what does that something have to be? Well, rearrange that to this, and then 1 divided by 0.05 would give me what that would be, and that's 20. And it has to mean that we've got 20 least counters in the bag. And we went through the one with the lowest probability, which was a red. Okay. And then we assumed that, well, there has to definitely be one red counter, wouldn't there? Definitely. And then work backwards to work out what my number could be. Okay, the next one. We've got a cumulative frequency graph and we have to work out the median. Well, your graph goes up to 60, doesn't it, here? So I need to go across 30. Let's see if I can zoom in. I've got my ruler. Oops. There we are. And what have I got now? Oops. Let's get rid of that. Let's put it there. I've got 55, 56, 57. Okay. Now, Jamil says 80 take away 40 is 40. So the range of the weights is 40 grams. Is he correct? Right. Okay. So I'm going to say, first of all, straight away, he is incorrect. And now I've got to prove it. Okay. So he's saying that 80 take away 40. So he's saying that the maximum weight is 80 and the smallest weight is 40. And I think he is wrong, okay, by just looking at the weights, yeah, by here and here. Because when you plot a frequency diagram, you always plot the upper bound, don't you, with the frequency. So you don't actually know what the real number is. So we can say, because maximum weight could be less than 80, or minimum weight also could be less than 40. Okay. Next question still to do with this. It says, show that less than 25% of the potatoes have a weight greater than 65 grams. Right, so 25% of 60 equals 15. Right. Then 25% of the potatoes have a weight greater than 65 grams. So what am I going to have to do? 60. Let's have a look. There's a weight greater than 65 grams. And what I'm going to do is I'm going to go up 65 actually. Where's the ruler gone? So let's get the ruler out. 65 weight, isn't it? Okay, there we are. Kind of, I did it as best as I could. Right, so that there is 49, isn't it? And it has to be greater than, so it has to be this number here. So let's do 60 take away 49 to work out what that number is, and that's 11. So I'm going to say 11 potatoes have a weight, oops, have a weight greater than 65 grams. Okay. And show that less than 25% of the potatoes, less than, there we are. We worked out 25% was 15, and we've worked out, there you are, less than, have a weight that is greater than 65 grams. Okay, the next question is a probability tree diagram worth 3 marks. So we've got Alan has 2 spinners, spinner A and B. Each spinner can land only on red and white. The probability that spinner A will land on red is 0.25 and land on red B is 0.6. Alan spins spinner A once and he spins spinner B once. He does this a number of times. The number of times both spinners land on red is 24. Work out an estimate for the number of times both spinners land on white. So, lots of different ways of doing this. It says both spinners land on white. So, first of all, it tells you that both spinners land on red is 24. So red, red. What's red, red? 0.25 times 0.6. That's 0.15, which is equal to 24. Yeah? So white, white. What's white? White is 0.75 times 0.4. 0.75 times 0.4. That on a calculator is 0.3. All right, well, we know if 0.15 is 24, that's double that. So 0.3 would equal 48. And that's our answer, 48 times. Okay. Next question. We've got complete the square, very simple and straightforward. Half your 6 to get 3. Take away 3 squared, whatever that number there is, and take away 7. Let's make it nice and easy. Take away 9, take away 7. That's not minus 3 squared, it's take away 3 squared. So be careful that you don't turn the 9 to a positive. And then x plus 3 squared minus 9 minus 7 is minus 16, and that's your answer. Don't be thrown off by this plus b and thinking that you definitely need a plus there and you haven't got a plus, and then spend a lot of time trying to find another solution just because you haven't got a plus. You don't need that. Okay, they're just there to trick you out. They're always going to plus there, they're never going to give you the minus there. Right, cone A and cone B are mathematically similar. The ratio of the volume of cone A, right, volume A to B is 27 to 8. Surface area, I have to show the surface area, right? I'm going to cube root these because I want to work out the scale factor for length. At the moment, that's volume, and obviously volume's 3-dimensional. That's why I have to cube root it. So cube root of 27 is 3. Cube root of 8 is 2. That's just for length. Now for surface area, I can obviously square them. So if I square 3 is 9, square 2 is 4. That is for area. Right, I know that the surface area of cone B is 132. Is that right? And the surface area, I've got to show that. It tells me the surface area of A is 297. Well, if I do 297 now, divided by 9, that gives me 33, and I could just times it by 4 then to get 132. And is that what they want? Yes, centimeters squared. And we've done what they want us to do. Quite simple and straightforward and very easy going. Let's have a look at the next question then. Okay, so show that this equation has a solution between x is 0 and x equals 1. Well, the first thing is you just substitute 0 and 1 in. So 0 cubed plus 7 times 0 minus 5. Well, that just is minus 5. 1 cubed plus 7 times 1 take away 5. 1 add 7 take away 5. That is 3. And I'm going to write, therefore, there is a change of sign. I've got 1 negative, 1 positive. Haven't we, number? There is a solution between 0 and 1. You have to write this change of sign business, and what you'll notice is there'll always be a positive and there'll always be a negative number when you substitute it in, and that's what you have to write in. Okay, right, let's have a look then at the other question. Yep. Right, show that the equation can be rearranged. Okay, so we're now going to rearrange our equation. Obviously, rearranging is quite simple and straightforward. Sometimes it's not, but you have to just have a look at what they want from you. And more importantly, you know, to make sure that you're not making any mistakes when you are rearranging. So I want to end up with x equals, and I know my x squared at the bottom, and I know my 5 is on the other side. So let's get rid of the 5 first. X cubed plus 7x equals 5. Okay, so I think now I'm going to factorize an x out, and I'm left with x squared plus 7 equals 5. Oh, and I can now divide by the bracket. And there we are. I've rearranged exactly how they want me to rearrange. Okay. Next question. Right. So now I've got to find a solution 3 times. So it tells you x0 equals 1. I've got to put 1 in there. So x1, when I put 1 in there, so I've got to do 5 divided by 1 squared plus 7. On my calculator, I get 0.625. x2 and x3. Right, now I've got to put x equals 0.625 in. I end up with 0.6765327695560. And the last one is 0.67044830001. And there we are, that is your final answer. Obviously, there is an answer line, so you would put your last answer in. And there you are. Okay. Let's have a look at the next question. By substituting your answer to part C into that, comment on the accuracy. Right, I've got to put my answer in. So I ended up with 0.6. Oops. Let's get rid of that. 0.6704483. Oops. Sometimes it doesn't really cooperate. So let's have a look. Let's go back, rub that out. Right, 0.67044830001 cubed plus 7 times 0.67044830001, take away 5. Right. Tap that into my calculator and I get minus 0.0054947691. Right, I'm going to say accurate answer. Because it is close to 0. And look, your answer should equal 0, and it is close to 0, hence why it is accurate. Right. Let's have a look at the next few questions then. Question 16, we've got petrol here, and we've got the formula for petrol consumption is given below, and we have to say, it says that Nathan's car travelled 148 kilometers, correct to 3 significant figures. The car used 11.8 litres of petrol. Nathan says, my car used less than 8 litres of petrol per 100 kilometers. Could Nathan be wrong? Right. Okay, so to know that, we're going to have to obviously work out upper bound and lower bound to see the difference between them. So we've got 148 and we've got 11.8. That's 148.5, 147.5, 11.85 and 11.75. Okay. Right, upper bound. is always upper bound divided by the lower bound. And let's have a look at the formula. So it's 100 times 100 and, no, it's 11, isn't it? Let's rub that off. Sometimes, obviously, it doesn't want to work. Okay, 11 litres of petrol is 11.85, isn't it? Divided by 147.5. Tap that into my calculator and I end up with 8.033898305. And it says my car used 8 litres of petrol per 100 kilometres, and he's right. Because look, we have got 8 there, 8.03. So he is right, isn't he? We've used the upper bound, obviously, because we wanted to know the maximum usage he could have rather than the less one. And we have found that, yes, he is correct because he ended with answer with 8.03. Thank you for watching.